Well, hello everyone, and welcome to One Sample Z testing. But we're actually going to start with something called the central limit theorem. So I want you to look over here and imagine that you have a cookie jar, lots of cookies, and there are three different sizes, like small, medium, and large. And you take samples out of that cookie jar. Each sample is 4 cookies big. So here's one sample of 4, here's another, here's another, here's another. And if you took samples again and again and again, and then plotted those samples, took the average size of the cookie that comes out of each of those samples, and plotted that, what you would get is a distribution that looks like this, a normal distribution, where in the distribution you've got not x's, but x bars, where x bars represent the average size of the 4 cookies. So each of those x bars that you see here represents the average size of 4 cookies in a sample. And what hypothesis testing is all about is trying to decide the likelihood of a particular sample belonging to a distribution. So in this case, at the tails of the distribution, you have 2 unlikely samples. It's unlikely that you'd have a sample that would have all big cookies in it. Could happen, but it'd be unlikely. And it's also unlikely that you'd have a sample that has just a bunch of little cookies. Could happen, but it doesn't happen often. You're probably going to get a sample that's got a mix. And so when we plot the average sizes from all our samples on the graph, something magical happens. And that is that even though the cookie sizes in the jar are all over the place, small, medium, and large, the averages from our samples will start to form a nice, smooth bell-shaped curve, the normal distribution. And the more samples you take, the more this bell shape becomes clear. And most importantly, the center of that bell shape is the true average size of a cookie in the jar, even if you never measured all the cookies. Why does it matter? The central limit theorem tells us that even if individual things, cookies, are randomly sized, the average size from the samples will be predictable and normally distributed as long as you take enough samples. This is why it's so powerful and widely used in statistics, science, and everyday data analysis. So, again, this is the probability now not of x, but of x bar, basically the probability of finding a sample where the sample size n equals 4. And as I mentioned before, it's unlikely that you'll get a sample of all small cookies, and it's also unlikely that you get a sample of all big cookies. Most samples will have a mix and will end up somewhere here in the middle. And this size here in the middle, this mean, is the true average size of a cookie in the population. So we'll come back and we'll reference the cookies throughout. We'll see you in the next video.